You will need to know how to solve a right triangle by using sine, cosine, and tangent. This lesson will show how to find a missing length as well as a missing angle measure of a right triangle. These will all be on the ACT college entrance exam. Now let's go to the classroom to review SOA katoa. Okay, let's talk about right triangle trig ratios. First of all, we're going to deal with sine, cosine, and tangent. Now we're dealing with right triangles now. So what we're going to do with sine, you have to remember how the relationship works. So I'm just going to write SOA for that, and I'm going to explain what that means in a minute. Cosine is CAH, and tangent is TOA. So katoa. That's what most people will show you in any geometry class as a way to remember the relationship of the ratios of these three trig ratios. Let me draw it so it makes sense to what we're talking about here. We have to start with the right triangle. Let me label this base angle A here, top B, and the right angle we'll call C. Now it all depends on which angle you start with or what you're referring to. So let's just make it easy. Let's look at angle A. If we wanted to find the sine of angle A. Now you notice that I'm not writing sine with an E. It's just an abbreviation of sine. Sine of angle A, well, what they're going to do is that's going to be the opposite side of angle A. That's why we have angle A over the hypotenuse. I'm going to abbreviate hypotenuse HYP. What sides would that be? Well, in this case, you want to start with the angle. The side opposite this angle will be directly across from it. So this is going to be the opposite side. What's the hypotenuse in this triangle? Hypotenuse is always, always, always opposite the right angle. So these are the two that I would get first. So this guy right here has got to be the hypotenuse. Well, geez, the only one left is the adjacent. And that's the hardest one to figure out. So I usually figure out what's the opposite of that angle. The hypotenuse is always opposite the right angle, so it leaves you the adjacent has to be the missing side. So in this triangle, the opposite side is BC, so I'm going to write BC over, let's see, then hypotenuse is AB. Now let's talk about cosine. See, sine, so opposite over hypotenuse. Sine is opposite our hypotenuse. It's the first letter in each one of those guys. Now let's do cosine. Cosine of angle A. I wrote ca. That means adjacent over hypotenuse. So it's going to be adjacent over hypotenuse. Well, what's the adjacent side? That's segment AC over the hypotenuse, which is AB. Last one's tangent. They'll write it tan of angle A. And that one, for tangent was TOA. Opposite over, tangent is equal to opposite over adjacent. So opposite over adjacent. So the opposite side being BC over the adjacent side, which is AC. Now, it just depends. If you're talking about angle B, these segments are going to change. So when you're setting up your ratios, you have to start with your angle, identify what's opposite, what's the hypotenuse and adjacent, so that way you can get the right side lengths. So now let's take a look at a problem. Okay, I'm going to give you a triangle, right triangle. A, B, and C. And I'm going to give you a length of 10 here and a length of 8 here. So AB, the hypotenuse is 10. AC is a length 8. And you're asked to find sine of A, cosine of A, tangent of A, and let's even go for the measure of angle A. Now, they probably won't ask you to do all this in one problem, but I want to cover as many possible situations as you can encounter on the ACT. So, before you do anything, you'll notice I purposely left out one of the missing sides. So you want to probably find that before you do anything. And if you remember, we're dealing with a right triangle. We've got the lengths of two sides. We've got the hypotenuse, and we've got one of the legs. We can use Pythagorean theorem. So we're going to have 10 squared is equal to 8 squared plus, we're missing BC, so I'll call it BC squared. 10 squared, that's 100, equals 8 squared, 64, plus BC squared. Subtract 64 from both sides. You're going to get 36. That's BC squared. And then to find what BC is actually equal to, you're going to have to take the square root of both sides. So BC is going to have to be 6. So now that we got that, we can find sine, cosine, tangent, and then we'll work towards finding the measure of angle A. So we're dealing with this angle. So if we want to find the sine of angle A, sine of A, you have to remember, sine is so, opposite over hypotenuse. What's the opposite side? This is going to be the opposite side, which is 6. The hypotenuse is going to be the 10. And the adjacent of this angle A is going to be 8. So sine is opposite, which is 6, over the hypotenuse, which is 10. You better reduce it because I'm sure they're going to give you a reduced answer. Let's see, 2 goes into 6 3 times, and then 5 times into 10. So you get 3/5 for sine of angle A. Cosine. Cosine, let's see, what was that? It was, there's so ka, so it's going to be adjacent over hypotenuse. We know the hypotenuse is 10. Adjacent is 8. So reduce that, and then it's going to be 4/5. Because 2 goes into 8, 4 times, 5 times into 10. Tangent. Tangent, let's see, we got to remember that's soa ka toa, O-A. So opposite, which is 6, over adjacent, which is 8. And if we reduce that, see 2 goes in that 3 times, 6 3 times, and then 4 times into 8, so we get 3/4. So we can do this pretty quick. You just got to know those relationships. Now, how are we going to find the measure of angle A? Well, let's see. What we could do is we can take any one of these three. Let me just start with sine A, we've already determined, is 3/5. What you could do is take the sine inverse of both sides. What it would give you is it would give you angle A equals sine inverse of 3/5. Now, before you even calculate this sine inverse, please make sure if you have a graphing calculator, graphing utility, please make sure you have your calculator set into degree modes, not in radians, because some classes you're working with radian measures and you're going to be wanting a degree measure in this situation. So make sure you have it in degree mode. That can give you a wrong answer, and I bet you they're going to have that wrong answer as a choice, and you thought you got it right and you didn't. So when you take sine inverse of 3/5, you're going to get 36.9 degrees. A lot of times, most math questions, they'll round to the first decimal place, so that's why I'm pretty sure that's what they're going to do in the ACT. Now you can do this with any of the other ones. You can find angle A, measure of angle A, by using the cosine. You would have, since you have cosine of angle A is 4/5, you would have angle A would be cosine inverse of 4 divided by 5. And it's going to give you the same answer. You could do the tangent inverse of what you got for tangent angle A, which is 3/4. All three will give you the same answer. So it depends. It might be a two-part question. They might ask for sine of angle A and the measure of angle A. Then you would use the first method. It just all depends on what they give you and what they ask for.